Hello students, welcome back to Engineers Academy. Now we are going to solve this problem from Vector Mechanics by Beer and Johnston, chapter 2. And the problem says that determine the x and y components of each of the forces shown. So we are given these three forces, 800 Newton force, 408 Newton force and 424 Newton force, and we are asked to find the x and y components of each of these three forces. So now this 800 Newton force will have one component, the f of x component in this direction. This one will be the f of x, and this one will be the f of y component. So now let's say that this is our positive x and y axis. This is the 800 Newton force, and let's say that this 800 Newton force is making some angle alpha here with the x-axis. So let's represent that angle here. Let's say this is angle alpha. So now if this is the angle alpha, if this 800 Newton force is making alpha angle with the x-axis, so f of x will be the cos component and f of y will be the sine component. So now this will be our f of x component of 800 Newton. This is f of x. Let's say this is f1. So f of x will be f1 cos of the angle made with the x-axis, so that is cos of alpha. Now since the angle is made with this f of x component, so this f of x component will be the cos component, or we can say that this f of x component is adjacent to the angle, so then this is the cos component. Similarly, this one will be the vertical component, this one will be the f of y component of f1, so this is f of y, and this one will be the sine component. So this is f1 sine of angle alpha. Now here let me represent that angle alpha here as well. So now we are given the lengths. We are given this length. This is 600 millimeter, and we are given this length. This is 800. So this length and this length, both lengths are equal. So now we are given this right angle triangle, and we are given the base and the perpendicular of this right angle triangle. And as we know from trigonometry that cos of alpha will be the base divided by hypotenuse. So now the base of this right angle triangle, this is the base. So the base is 800 and this is the hypotenuse. So now the hypotenuse is not known. So let me write that the base is 800. For F1 equals to 800 Newton, the base is 800 millimeters. So that is 800 divided by the hypotenuse. And the hypotenuse is the diagonal of this rectangle. So this is the hypotenuse. We need to find the hypotenuse, and the hypotenuse can always be determined by using the Pythagoras theorem. So now we are given this right angle triangle. So from Pythagoras theorem, the hypotenuse will be equal to the base square plus the perpendicular square under the square root. So now we can say that the hypotenuse for F1 will be 800 square plus 600 square under the square root. So now let's find the hypotenuse. So that is 800 square plus 600 square. So this is 1000. So the hypotenuse is 1000 millimeter. Since these lengths are given in millimeter, the dimensions are in millimeter. So now from this point O to this point, this length is 1000 mm. So now we can find the cos of alpha. The cos of alpha will be 800 divided by the hypotenuse length, which is 1000. So cos of alpha is 800 divided by 1000. So this will cancel out. So we can say that this is 8 divided by 10. And similarly for f1, the sine of alpha will be, if this is the angle alpha, so sine of alpha will be perpendicular divided by hypotenuse. So now the sine of alpha is perpendicular, the perpendicular is 600 and the hypotenuse is 1000, or we can say that this is 6 divided by 10. Now as we have discussed that the f of x for f1 is the cos component, this is f1 cos of alpha. So now we can write that for f1, we can write that for f1 equals to 800 Newton. F of x is f1 cos of alpha. Now f1 is 800, this is f1 cos of alpha. So 800 cos of alpha, this is our cos of alpha. So this will be 800 and cos of alpha is 8 divided by 10. Similarly, f of y will be this f1 sine of alpha. So 800 sine of alpha, 800, and now the sine of alpha is 6 divided by 10. So now we can find the magnitudes of the components. That will be 800 into 8 divided by 10. So this is 640 Newton, and similarly that is 800 multiplied by 6 divided by 10. So that is 480 Newton. Now to represent the directions of f of x and f of y, we need to put the plus and minus signs. So now as we can see that f of x is acting in the positive x and f of y is also acting in the positive y. So we need to put plus sign here. So this will be, we can say that f of x magnitude is plus 640 Newton and f of y magnitude is plus 480 Newton. Now we have to repeat the same procedure for f2 and f3. Let's say this is my f2. 408 Newton. Now f2 is 408 Newton. Again, it will have f of x and f of y component. So f of x component is, let's say this is f of x component of f2 and this is f of y component of f2. This is f of x and this is f of y. F of x is acting in the positive x and f of y is acting in the negative y direction. And let's say that the f2 is making angle beta here with the y-axis, let's say. So let's say this angle is beta. Now the angle is made with the f of y component. So f of y will be the cos component. So we can say that for f2 equals to 408 Newton, the f of y is the cos component, which will be f2 cos of beta. Since the f2 is making beta angle with the f of y, so the f of y will be the cos component, remember. So f of y is f2 cos of beta, and similarly the f of x component will be the sine component. So we can write that f of x will be f2 sine of beta. Now we have to find the cos of beta and sine of beta using these dimensions, using these lengths. So now again we can consider this right angle triangle and this is that angle beta. So cos of beta will be this base. So this is the base divided by the hypotenuse. So this is the base, this is the hypotenuse. So now we can write that cos of beta is the base, which is 900, divided by the hypotenuse. Now this is the hypotenuse. This diagonal will be the hypotenuse for this right angle triangle. Again, we can use the Pythagoras theorem. So to find the length of this hypotenuse, we can use the Pythagoras theorem. So that will be 900 square plus 480 square and under the square root. So we can write that cos of beta will be 900 divided by 900 square plus 480 square under the square root. So this will be cos of beta. So now let's find the hypotenuse first. So that will be 900 square plus 480 squared. So this is 1020. So cos of beta is 900 divided by 1020. Similarly, the sine of beta will be, now the sine of beta for this triangle will be the perpendicular. So this is the perpendicular divided by the hypotenuse. So sine of beta will be 480 divided by the hypotenuse, which is 1020. So now we can find these components f of y and f of x for f2, 408 Newton. So this will be f2 magnitude is 408 and this is cos of beta 900 1020, and similarly this f2 is 408 and this is sine of beta. So 408 multiplied by 900 divided by 1020. So this is 360. The f of y is 360 Newton, and similarly the f of x is, this is 480. This is 192 Newton. So these are the f of x and f of y components of 408 Newton. Similarly, we are given this 424 Newton, is 424 Newton. And again, we are given these dimensions, and let's say that this before going to find the f of x and f of y components, first let's represent the direction of this f of x and f of y. So f of x is acting in the positive x, so this will be positive, and f of y of this f2 is acting in the downward direction, so this is negative. So this is negative and this is positive. Now let's say this 424 Newton, this is, let's say, f3. So this is f3. Now for f3 equals to 424 Newton. So again it will have one component in this direction. This one will be the, again, f of y component like this, and this will have one component like this. This one will be the f of x for f3. Now let's say that f3 is making angle gamma here, let's say. So now this is f3, this is f of x component, this is f of y component, and let's say it is making angle gamma with this f of x or with the x-axis. So now if this is angle gamma, then f of x will be the f3 cos of this gamma angle, since the angle is made with this f of x. So now we can write that f of x for f3 will be f3 cos of gamma, since we have assumed the angle with the f of x. So this one will be the cos component, f of y will be the sine component. So f of y for f3 will be f3 sine of gamma. Now again we are given this right angle triangle, so we have to consider this right angle triangle, and cos of gamma will be this base divided by hypotenuse. Now the base is 560, so we will write that cos of gamma will be the base is 560 divided by the hypotenuse. Now this is the right angle triangle. Now the length of this hypotenuse will be 900 square plus 560 square under the square root. So this is 560 divided by 560 square plus 900 square under the square root, using the Pythagoras theorem. So 560 square plus 900 square. This gives us the hypotenuse equals to 1060. So cos of gamma is 560 divided by 1060. And similarly, the sine of gamma will be the perpendicular divided by hypotenuse. So now again, this is our right angle triangle. So for this gamma, this is the perpendicular. The opposite side to the angle is always perpendicular. So this is the perpendicular divided by hypotenuse. So the perpendicular is 900. So 900 divided by 1060. So now we know that f of x is the cos component, f3 cos of gamma, f3 is 424. So now let's write that f3 is 424 and cos of gamma is this. This is 560 divided by 1060. And similarly, f3 is again 424 and sine of gamma is 900 divided by 1060. So 424 multiplied by 560 divided by 1060. So this is 224 Newton. So the f of x of f3, 424 Newton force is this, 224 Newton. And again, the f of x component of f3 is in the negative x. This f of x is in the negative x, so this is negative. So we will write that this is minus. And similarly, this f of y is 424 into 900 divided by 1060. This is 360. And this f of y is also acting in the negative y direction, so we will put minus sign here. So this is minus 360 Newton. So these are the components of f of x and f of y components of f1, 800 Newton. These are the components of f2, 408, and these are f of x and f of y components of f3. So I hope this will help you in your learning. Do like and subscribe my channel if you people think that this helps in your learning.